comparator interface has undergone a lot of changes when Java moved from version 7 to version 8. So here I have opened comparator API Java doc basically for version 7. So as you see here, the comparator interface in Java 7 had only two methods: compare, which would compare two arguments for order, and equals. Equals is nothing but the commonly used equals method of the object class. So which is, as you know, is defined as boolean equals object, and we normally override this for whenever we want to compare two objects of a type. In Java 8, however, the comparator has undergone a major change. So now instead of two methods, you have 17 methods. Yeah, you heard it correct. 17 methods. So you do have the original compare method, but along with it, you also have a new method comparing. You have various overloaded definitions of comparing depending on how you want to use it. So you have a comparing with a comparator again. Then you have comparing double, which extracts a double sort key. You have comparing int, comparing long, then the equals, which is one of the two methods which has to be there, because equals you do provide as an override option over object. And then there is a natural order method added to the new comparator interface that returns a comparator that compares comparable objects in natural order. You have nulls first, nulls last, you have order reversal. You can chain comparators together using then comparing. So you have, if you have multiple sort criteria, then you can put comparing and then comparing after that multiple times. And then comparing also has multiple overloaded variations. And then finally you have then comparison of int and long apart from double. So these are default methods. As you see, many of these are default methods, many of these are static methods. Since it's a functional interface, so comparator in Java 8, and this is the most important point actually, comparator in Java 8 is a functional interface. Whereas in Java 7 it was not, because in Java 7 there was no definition of a functional interface itself. Functional aspects of programming were introduced in Java 8, and one of the basic requirements of defining a functional interface is that it should have a single functional method, that is abstract method. So if you see comparator interface, it still has a single method, abstract, compare, that remains the same. The other 15 methods apart from equals, which is the 17th method, the 15 methods which have been added are all either static methods or they are default methods. In case you are new to functional interfaces or Java 8, then I have a separate video tutorial for explaining the concept of functional interfaces, Lambda expressions, streams and all those. Here at the moment we are focusing on how comparator has changed in Java 8. So let us now first start with understanding what basically a comparator does. As in, till Java 7 what was comparator doing, and then we can build upon what new has been added to it. So to understand what comparator used to do in Java 7, until Java 7, let's see a comparator object. Now I have used an employee comparator here to explain the concept of a comparator. So let's open up employee. So as you can see, my employee class has name, age, it has an employee constructor, and it has getters and setters for name and age. It has a toString which prints employee name, employee age, and then there is a equals method which compares to employees, and there is a hash code method. So it's a typical POJO, plain old Java object. Now when we open up our employee comparator which implements comparators, now remember this is I'm using Java 8 libraries here, but this is typically how comparator was used till Java 7, and you can still use it this way in Java 8, but the point is to first show you what was possible earlier in comparators and what we can do better in Java 8. So if you see here, so this employee comparator implements comparator of type employee, and it compares emp1 emp2 of type employee, and it basically compares using the compare to method. It compares employee1 dot get name and to employee2 dot get name, or it compares the names of the two employees. Compare to is the natural comparable interface method, which so that means it's using the natural comparison order implemented using comparable in strings. Okay, so far so good. So now we have an employee with name and age. We have an employee comparator which uses name to order employees. So our employee with the name A will appear higher in the list than an employee with the name B when we use this comparator to sort. We come to a class called Comparator old P, which is nothing but Java 7 way of comparison. In this class, I create a static list of employees. I give them names and ages. As you can see, the first name starts with T, the second with H. The third again is the name is the same but age is different. So this will be useful for us when we use multiple sort orders. At the moment, we are however focusing on getting our first sort done using name. The main method I call collections.sort method, which is, as you might be knowing, is the standard way of sorting a collection. And I pass to it the first parameter as employee list and the second parameter as the employee comparator, which we had written a little while back. And this employee comparator, and see, if you see, compares by name. So, and in the next step, I am using a for each to print a sorted list. Now let's see what happens when we run this. So we need to open up the console because it's not showing up by itself. Okay, here's the console and we place it down here, and as you can see, the employees have been sorted now. Though the first employee in our input list was Tom, starting with a T, Tom is now the last employee because T is the maximum alphabet here. And before that, if you see D, E, H, H, and T, which is perfectly in alphabetical order. Now this shows that the comparator, the traditional Java 7 way of comparing, is working and you are getting a sorted list. Now the next step is to, okay, so now we have seen how Java 7 works. In case we wanted to sort by age, you can probably guess by now that you have to, this part you have to implement a new employee comparator by age, and you can name it by age, and this one you can name it by name like this, and then in that you will compare employee age to employee age, employee 1 age to employee 2 age, and that employee comparator by age can be passed here instead of new employee comparator to compare your elements. Okay, so if you wanted to do multiple sorts based on multiple sort criteria, so for example, first you want to sort a list by alphabet, and then you want to sort that list, you want a second sorting criteria. That would have meant that you would have come here and done some logic here in this method. So as you can see, it would get a bit messy in Java 7. So you would need a first level sort for name, then you would compare the age here, name, age, and see if the name is same, then you will have to keep the shorter, younger age rather to on the top and the elder age employee next. So instead of doing all that, as I will show you now, comparators in Java 8 make all this quite simple. So first of all, let's start with understanding what new does comparators in Java 8 provide for you so that you get the confidence of doing much more. First of all, as I explained earlier a little while back, that comparator in Java 8 is a functional interface. So if you see, it is defined like this in the library. So the fact that it is a functional interface implies that it can be used as an assignment target for a lambda expression or a method reference. Now this point is very important. What it means is you can write something like this. So I come back to my old way and let me make a new class itself. Comparators, new way, comparators in Java 8. Okay, and then I would generate a public static void main. I would copy the same static list here. And put it here. So now we have an employee list. So when we say that functional interface can be used as an assignment target for a lambda expression or a method reference, so I assume you are already aware of lambda expressions and method references. In case you are not, then there is a separate tutorial on method lambda expressions and method references each, so you can probably go through that. However, now even if you don't know, you can just follow, but you need to know what is a lambda expression. So I hope you know that, and in case you don't, then you can see this tutorial and then you can check out Java Brahman's YouTube channel and see the lambda expressions tutorial as well. That would help you in understanding this example better. Okay, so returning to my point where I was telling that comparators in Java 8 can be defined using lambda expressions. So I can do something like this. So I say a comparator, I do a control space in Eclipse, and I get few options. So I'm going to use a comparator, and it's of type employee, and what I'm going to say is employee name comparator. So I'm basically making whatever I made in Java 7 using this employee comparator where I use name to compare. I'm going to create the same thing, but you watch how easy it would be. So I would say employee name comparator, and then so we have named it employee name comparator. Now the next step is to provide a lambda expression defining our comparison. Okay, let's see how that works. So we have an employee EMP. Okay, so we have an employee EMP1. We have an employee EMP2. And what does this lambda do? This lambda does a EMP1, or basically if you come here, whatever this guy was doing here, right? So I can come here and I can write like this, and of course it's a lambda expression, so we need to write it like this. And then here I need to provide round brackets. Okay, so this is our lambda, which takes employee1 and employee2 as input, and it returns a natural comparison of the two names of the employees passed to it. So this is called, this I name it an employee name comparator. Okay, so far so good. Now if you go to the old way method, what I did here, I'm just copying the same thing here, but you will notice the difference. I come here Okay, I have the collections dot sort employee list, the same employee list I have copied here, and I'm doing an employee name comparator. So this was the result from our previous Java 7 run when D came on top and T. So we expect to see the same here, and then I'll explain how it worked. So you can see it worked the same. D on top and T at the bottom. So how it worked is, this lambda expression that you see internally creates an instance of a comparator implementation. Okay, I'll repeat that. This lambda definition internally creates an instance of a comparator implementation, and that comparator implementation with this logic is assigned to the variable, or rather the object name employee name comparator. So what you have here is in fact a new employee name comparator object, which is of the type of comparator with type as employee. And then we are doing the same thing which we did here. We are calling collections.sort of the employee list and the comparator class instance. Same thing we are doing in comparators in Java 8. We are passing the employee list, and now we are passing an instance of a comparator created using a lambda expression. And then we print out the elements after they sort, and they are sorted properly. So this basically shows how easy it has become to define your comparator using a lambda expression. If you see, the old way, you had to create a class, employee comparator class. This employee comparator class, you would create a class, you would go here, you would use a new instance of that. All this employee comparator class creation is reduced to just this, a lambda expression. So as you can see, defining a comparator has become that much simpler because it is a functional interface and it can be assigned a lambda. It makes it much more simpler.